Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through the journey of trigonometric substitution. In previous episode, we kind of look at other techniques or methods for solving integral problems, the likes of substitution by integration by substitution, integration by part, and other method like integration by numerical approaches, where we kind of dive into the Riemann sums, the trapezoidal rule, the midpoint rule, and then the Simpson's rule. But it's another interesting technique that we kind of use or employ to find an area of a center or an ellipse. Sometimes some integral problems that we are being confronted with um, would would require that we know certain technique, and this technique is what would enable us to solve problems like that. So stay with me, and at this point, if you have not subscribed to my channel, please do so. Like, share, turn on your notification button so that anytime I upload new content, you'll be the first to receive that. And also, let's help to demystify the myth around mathematics. Let's get going. So in finding the area of a circle or an ellipse, so in finding the area of a circle, let me be more. So let me just. So in finding the area of a circle, ellipse, sometimes an integral of the form arises. An integral of the form arises. Where over here we kind of state that the constant A is positive. Okay. And you see, if it were, let me be more specific here. If it were an integral problem like this, the substitution, u equal to, maybe the substitution u equal to a squared minus x squared would be more effective. Okay, if it were to be this, then this substitution will be more, effective in handling the problem. But as it stands, we have this particular integral problem to solve, which is more difficult, is more difficult. So in which case we have to kind of look at it from a different perspective. Okay, and that is where today we are going to take our time to go through in order for us to have an in-depth knowledge of what it is when a problem like that is, arise. Okay, so in that case, we may want to change from one variable. In this case, the variable we are concerned about is x, so we want to change from x to maybe theta. Okay, by the substitution. Okay, then so in this case we wanna over here we wanna switch from, okay, so over here we wanna move from, so we do what we call change of variables. Okay, so for us to solve this problem, we do what we call change of variables. Change of variables, in which case we want to move from, x to theta. Okay, we want to switch from x to theta. Okay, does that make sense? Then we come out with a substitution. Okay, we kind of come out with a substitution that x should be equal to the constant in the integrand, which is a. Then we multiply that by sine of theta. Okay, then this identity, I know we are. Then this identity. So this identity, I know we are much familiar with this. Will be equal to what? Will be equal to the cosine square theta. Okay. Uh, but this would, allow us to kind of get rid of the sine root of the root sign. Okay. This would enable us to get rid of the root sign. So in which case, when we kind of substitute that into, let me be more specific here. So if we kind of do the substitution, then we are going to have this to be equal to the a squared minus, now your x is now what? A sine theta, right? So when you kind of do the replacement, so we are doing the substitution using this, okay? So when we do that, we're going to have what? A squared. And when we factor out A, but so far we said that this is what? From this, okay? From this, we said that that is equal to what? That's equal to cosine squared, okay? So we're going to have A squared cosine square theta. And that'll get rid of that, okay? The root sign, get rid of the squares, and that gives us what? A cosine theta, okay? Good, 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 good. So in which case, when we see this, what comes to mind is when we want to simplify this, this is the expression that we'll get, okay? Very good. So I mean, I'm trying my best to lay the foundation so that when we start, you would you would like it, okay? So let's get going. Let's get going. With time, I think will be okay. I will take my time to go through everything, so don't worry. So in order for us to kind of lay the foundation or to give everybody opportunity to really understand or to grasp the concept, I'm gonna construct a table, and with a table, we're going to base on that to solve problems. Okay, and if time permits, we'll solve some real world problems that we can use this. Okay, all these techniques. Very good. So let's call some expressions like some expressions. So the first expression I want us to kind of talk about. So the first expression. So let me say this is expression, and we kind of look at the substitution we can employ here. Then we want to look at the identity. I know the identity um all of us may be quite familiar with, but would revisit them. Okay, don't worry about that. So if I give you an expression as this, which substitution should you use? So far, we are quite familiar with it, okay? So when we see expression as square root of a squared minus x squared as an integrand, okay, then in order for us to solve that, the best substitution will be x equal to what? S equal to a sine theta, okay? And then the theta should be such that it should lie within what? The theta, we want to restrict the theta within this domain. Okay, very good. So from positive 90 to negative 90. Is that okay? Very good. And then the identity, as we have seen before, the identity will be what? 1 minus what? Sine squared theta. So the identity that I want to have in mind is this, or the identity that is associated with this problem, you know, will be something like this. Okay, good. Let's look at the second expression. The second expression I want us to look at is the square root of um, a squared plus x squared. Okay. And in such situation, the best substitution we want to employ will be the what? Will be tan theta. Okay. And we still want to restrict the theta to lie between positive 90 and negative 90. Okay. Very good. And then the identity associated with such expression should be what? Should be 1 plus what? Tan squared theta. What is 1 plus tan squared theta? If we can recall, and that is what? Sec squared theta. Okay, very good, very good, very good. All right, so let's look at the last expression that I want us to look at. And then with this one, what do you think the substitution should be? So the substitution should be x equal to x sec theta, and then theta should be, this time around, theta should strictly lie within, um, it should lie within, 0 to the 90 degrees, okay? Which is the first quadrant, right? Good, 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 good. And then or it should lie 180 and then what, 270, okay? And then the best identity associated with this can come from here, okay? Can come from here by making um time sec squared and to standalone, okay? So squared to standalone. But we're doing so when I have something like, okay, hope it makes sense. So the most interesting part is for us to kind of know our expressions very well. We have to try our best possible to kind of familiarize ourselves with the expressions so that when I give you some integral problems and you see something like this, you don't fumble. You just know that, oh, this is the expression um I kind of talked about, and you just use that to solve your problem. Okay. All right, so let's get going. We wanna tackle the first problem of the day. And so let's get the first problem of the day. So the first problem of the day, you wanna evaluate. So example one. So we wanna evaluate. So we wanna evaluate the integral. So we wanna evaluate the integral of square root of 9 minus x squared over s squared dx. Okay. So how do you solve this? How do you solve this problem? And what expression can we associate this with? Straight away, we kind of see that the expression x squared minus x squared can be associated with something like this, right? Can be associated with can be associated, let me say, can be associated with a square root of 9 minus x squared. Okay. The reason being that, we can write this as what? 3 squared minus what? X squared. Okay. Very good. So on that note, per what we learned earlier on, we said that this expression has the substitution with x equal to what? A sine theta. Okay. So by doing so, or by leveraging that, we can have x to be equal to what? What is now my a? My a is 3, okay? From here, so my a is 3. Okay, very good, very good. So with that, remember we are now transitioning from x to theta. So we want to have that in mind, okay? So with that, um, we kind of make sure we working within that transition, okay? So it means that my dx, now we have to transition, or we have to change this dx, okay? So now I need to find this dx. So my dx from here will be what? Will be what? 3 cosine theta or theta, okay? Very good, very good, very good. And but mind you, we said that theta should lie where? Theta should lie within what? Negative pi on 2, and then theta. Okay, that's what we said. Very good. Let's take note of that. Very good. Okay. Then what then becomes, so it means that my root of 9, which we also said that can be written this way, would now be what? When we do our substitution, now our 9 is 9, and our x is what? Our x is what? This is our x, okay? So our x is 3 sine theta. Now when we need to square that, okay? And when we simplify, we gonna have what? 9 minus 9 sine square theta. Now, when we factor out the 9, we're gonna have something like this, okay? And when we further simplify, we should have 9 cosine square theta. And that should give us what? 3 absolute cosine theta, okay? And that should give us just cosine, okay? Very good. So we have this. It means that when we kind of simplify, you know, when we simplify this very expression, we should have this, okay? By having that substitution in mind, we should have this result, okay? So now it means that our problem is solved. Now we go back to the problem that we're given. Per the problem, we're given something beautiful as this. Now, what is the square root of 9 minus x squared? Now we found it to be what? 3 cosine theta, okay? And what is x? My x we know is what? 3 sine theta. But remember it is squared, okay? And what is my dx? From here, my dx was what? My dx was 3 cosine theta theta, okay? Very good. Now, when we further simplify, we should have what? We should have cosine. There'll be some cancellations. So you should have 3, we should have, I think we should have 3 cosine, yeah, because the 3 cosine theta over 9 sine square theta theta theta, right? All right. So now when you further simplify, we should be able to have cosine theta over sine square theta d theta, okay? And from trig, cosine over sine is always cot, okay? So if it is cosine squared and sine squared, it just means it has to be what? Cot squared, okay? So you're going to have this, the integral of cos squared theta d theta, okay? Very good. Now, we can, kind of simplify this a bit. We can simplify the cot. And cot can always be simplified as what? Cosec, okay? Cosec squared theta minus 1, okay? Good. Now, we, by the property of linearity of integration, we can distribute, right? But when you distribute, what's the integral of cosec squared? The integral of cosec squared is always what? It's always minus cot theta, okay? And then the integral of 1 will be what? Will be theta, okay? Then we add a constant. Let's add a constant. And as I said, this constant is just an arbitrary constant, okay? It's important that we do that. Now, remember that the problem, we need to leave the problem in the form of x and not in theta, okay? That theta was just a transition that we made in order for us to solve the problem, okay? Now we have to reflect, we have to do a reverse substitution, okay? So it's important that we kind of have that in mind. Very, 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 very important, okay? Very important. So let's take note. And the easiest way for us to transition, we have to use this. For us to transition, we have to rely on this, remember. We said that x, from our analysis, we saw that x was equal to 3 sine, let me take my time, write it well. From analysis, we saw that x was equal to 3, oh my goodness, 3 sine theta, okay, from our analysis. Now, which means that my sine theta should be equal to what? should be equal to x over 3, right? Now, over here, we're going to apply um some uh, um some algebra here, okay? And by remember that sine, we said is what sine is defined. Sine theta is always defined as what? Remember, sine is associated with so which is opposite of our hypotenuse, okay? So we can make that drawing, okay? So we can draw that. So we can draw that as beautiful as this. Now we know that our hypotenuse is what? Our hypotenuse is what? Is 3, right? And then our opposite, if this is our angle, our opposite will be what? Will be x, right? So in which case we will need the base. How do you find the base? And the reason why we will need this is because, remember, we need to change the cot. Now the cot, remember, cot is what? Cot is cot is defined as what? Remember that cot, cot, okay? Cot is defined as what? As cot theta is always cosine theta over what? Sine theta, okay? That is cot. Very good. So let's take note of that. Is that okay? So that's what we have to bear in mind. So remember that we already have our sine, we don't have the cosine. So remember the cosine is what? Cosine is always what? Your cosine. So let me use a different pens. Remember cosine theta will be what? Which is cosine, which is adjacent over the hypotenuse. Your adjacent is where we don't have it. So we need to find it, right? We don't have this. And by um using the Pythagorean theorem, would find out that our adjacent will be root of 9 minus 4 x squared by using the Pythagorean theorem. So in which case our cosine theta should be what? Should be root of 9 minus what? X squared over the h. Okay? Please, do we understand this? Are we all getting it? Okay, so let's get going. Let's get going. Let's get going. All right, so we have that now, which means that my cot theta, okay, will be it is cosine theta over the sine theta. Okay. Now what is my cosine theta? My cosine theta is what? Root of 9x squared over 3, then divided by sine theta. So when we divide, we have sine over here. So we can reciprocate it, and that gives us what? 3 over x. So on that note, we're going to have what? Root of 9 minus x squared over x as our cot theta, okay? So we have to bring it back. But then we also need theta, right? But then because already we know x to be equal to, sorry, we know sine theta should be equal to what? To be equal to x, to be equal to x over 3. It is easy. So to find the theta, we just find out the sine inverse of x on 3, okay? So, and our solution, which is should be equal to what? So from here, it should be equal to, which was something like this. Now we know our cot, right? Our cot is what? At this particular value, okay? So we're going to have minus root of 9 minus x squared over x. Now our theta is what? The sine inverse of x on 3, then plus the constant c. Okay? Thank you so much for your time. All right, bye-bye.